So NASA Ames is one of the larger NASA research centres. They have a focus on aerodynamics and re-entry systems, but they do other things as well. It's notable because it's got the largest intern intake program. So for me, that was, it was nice being a big part of a big number of students there as well. And yeah, on the whole, they have really fantastic experts working on a whole load of different things. So there was 4 Kiwis there. Overall, there were about 250 interns, so quite a large number, and about 40 of those were internationals like me in the International Internship Program. Superball is what's called a tensegrity robot, which means that it's made out of rods and strings, essentially rods and cables. And the idea with the tensegrity robot, they're quite hard to visualize, so feel free to Google it if you're watching this. But the idea is that they are lightweight robots that are very good at absorbing impacts, and they're very good at traversing terrain that might be unexpected or rocky or things like that. And so my project was looking at different ways of controlling a tensegrity robot. They're quite new still, and so there's still some unsolved questions about what's the best way to get them to roll across the ground or to get them to walk around. The project itself was entitled Neuromorphic Control of a Tensegrity Robot, and what neuromorphic means in this context is the controller is inspired by the way that our biological brains work. It's still running inside a computer, and all the there's a whole load of different kinds of neuromorphic hardware, which I won't go into. But the idea is that we want to make it's a biologically inspired robot, tensegrity are biologically inspired. Maybe we could have a biologically inspired controller as well, where we've got an intelligent sort of oscillator as opposed to just a simple mathematical model. It was absolutely fantastic. There's definitely a weight that the organisation carries because of its history and because of its culture. It's not just the things they've achieved in the science realm, but culturally even, they were one of the first they're the only, for instance, they're the only federal government organisation that's involved with a pride parade, for instance. And they were one of the first organisations to hire people of colour in terms of a government organisation and things like that. So they're not just cutting edge because of the science that they do, but also because of the cultural parts of it as well. Definitely one of the highlights for me was I think just living on site. So it wasn't just that we were working there, because the way the internship programs work, essentially a very large number of the interns, probably up to about 190 of them, we actually lived on site as well in a place they call the Exchange Lodge. So from a terms of cultural exchange, maximising the time that you're spending on site doing cool NASA stuff. In some of the evenings we would go out with telescopes and we watched the ISS fly over one night, stargazing and things like that. That was really, really fantastic as well. Yeah, I think it was a mixture of having both the social side of things by living on site and then also the technical side of having such a fantastic job and a fantastic place to work. So I don't have a robotics background, so I had to pick up quite a lot of robotics stuff in order to get the robot to do things. But in addition, despite doing some things with machine learning in the past, I'd never used the particular type of machine learning we'd used before, which is spiking neural networks. So kind of a two-pronged learning for me with both the robotics side of things and the way we were controlling it. Fortunately, I was able to pick that up in the limited time that we had. We don't have, for instance, tensegrity robots in New Zealand, so kind of the only place you're going to be able to work on them are at places like the NASA research centres. And the other equipment that we were able to use, so they have a roverscape, which is where we were testing it, which is simulating the surfaces of other planets and things like that as well. Anyone would actually. I think a lot of the interns coming out of it were like, hey, this was really cool, I really enjoyed working here. It's quite common for people who intern at NASA to eventually go back and work at NASA. As it turns out, you talk to a lot of the staff members there and they're always like, I started here as an intern as well. So definitely there's a bit of inspiration that comes from that as well, for sure. Both of the areas that I worked in are still quite new, so using spiking neural networks to achieve things is a relatively new area. Spiking neural networks themselves are not new, but they've been kind of limited to the research space for a while, just because they're very hard to work with. they're now starting to see more interest in both the research and commercial fields. So having some experience with those is quite valuable, especially since New Zealand's got this burgeoning software area now where we want to do more and more intelligent things. So that's quite useful to bring that kind of knowledge back, but also in robotics as well, especially in the case where we've got companies now like Rocket Lab, who are, they're essentially a rocket that goes to space is just another kind of robot. And so any kind of experience that you get working on robotics and things like that, it's very useful to be able to apply to companies and organizations back in New Zealand as well.